Hello, welcome back to Code Catalyst Academy, and today we are going to cover arrays. So if you watched the previous video about strings, you'll learn that strings and their positioning are make it so that the first element, h, is actually the 0th index. The second element, e, is the first index, and so on and so forth, just so that the fifth element or the fifth character of O is the fourth index. And so that's like essentially what we call an array. An array is a way of storing data. And the good thing about arrays is that arrays can access any element instantly. This is in contrast to something like to advanced data structures like a linked list that you'll find in your average like college level data structures and algorithms course, where you have to basically like go in order throughout the elements. Whereas with an array, you can just access any element randomly. Yeah, it's your freedom to do that. And then the big thing about Java arrays specifically is that you once you like declare them and instantiate them, you cannot change their size. Their size is flexible. Their size is fixed, and so their size can be changed, but individual elements can be changed. And then the dot length method is used to get the size of the array. For example, if we do if we do int nums equals yeah, we can do 5. Let's do 3 actually. And then if we do nums 0 equals 1, nums 1 equals 2, and then nums 2 equals 3. And we can just get out nums. Oh yeah, but oh yeah, if we just actually just okay, it's just gonna return the memory. Yeah, I suppose. Yeah, it's just gonna return uh the first index or the first index or the second element. And we can do that. We can do nums dot length, no parentheses. This is in contrast to the string dot length function, which requires a parentheses, but it'll just return 3. And then we also have, if we wanted to do like, yeah, let's do nums 3 equals 4. And you're going to see that we cannot do that because it's index 3 is outside of bounds for length 3. We set this array to have a max length of 3. And this adds a fourth element to that array, which we can't do. So yeah, cannot do that. Yeah. And so yeah. And why is it zero index? Basically, zero indexing, it's meant as a measure of distance from the starting element. And since the first element is 0 away from the first, since the first is the first element, it's the 0th term. And since the second element is one element, away from the first element, then it's 1 away. It's 1. Here's an array visualization. You'll see that we have the 0 indexing, and this just shows all the indices. And here we have all the elements, and this is just another diagram, but it also has the memory locations of each specific element as well. Okay, and then here we have just an example of one way to declare and instantiate and initialize an array. Basically, you can just, if you already know what's going to be in it, you can just declare it like this. You have the type, the brackets, the variable name, or the array name, and then you have your elements inside of here. And this automatically infers the size of the array that you're making. It'll automatically infer that it's a size of 5, since this is all the elements that you gave it. So this will print the 0th index or the first term. This will print the first term or the first index of the second term, and then this will print the second index of the third term. So yeah, this is another way. Basically, you're just making a blank array of length of 5. Basically, this after nums before like line 4 or 5 is basically an array of length of 5, and all of it is going to be filled with zeros since nothing is in it technically, since you haven't like added anything to it. So here we're just assigning 1 to the 0th index and so on and so forth. Pretty simple. And here's the thing. Again, you have to assign the array size before inserting elements, whether that's by like inferring it with this or declaring it like this. And so you have to you can't just you can declare it like this, but you also have to like initialize and instantiate it with this. You have to declare like a new array of size 5. And you'll find that this results in an error because you haven't like given it a size, whereas you've given this one a size, and that'll work. Here are just some applications of arrays from Geeks for Geeks. You'll find like we have sorting, searching, storing and accessing data. That's like the obviously the most that's the most obvious use case. But you also you have like more data structures like stacks and queues. You have graphs, dynamic programming stuff. If you go on to study computer science in college, you'll learn about all of these in your freshman year data structures and algorithms course. But we also have real-time applications. We have stuff like signal processing, uh, multimedia applications, basically like uh, the array elements are basically more arrays that contain like the RGB values essentially, and then data mining, robotics, real-time monitoring and control systems. They're basically anything that concerns data and like technology and computers will use an array of some sort. And yeah, multi-dimensional arrays. So a multi-dimensional array is an array of an array. Instead of like having an int bracket nums where the elements are numbers, for this multi-dimensional array, each individual element is an array. It's another array. So the syntax is the first bracket. If you were to like get a certain element out of this array, the first bracket indicates the array that you want. So the zeroth array is this one. The 0th index is this one, or the first array. And then the second indicates the specific element in the array if you want. So the 0th index in here, the first element is 1. So it'll print out 1. And then here we have the first indexed array, or this array, and then the third index, or the 4th element. So 9. You'll get 9. And then here's just another way to think about multidimensional arrays. You can think of the first number as the row. So row 0, row 1, row 2, row 0, row 1, and row 2. The second is the column, or like each specific, the second is the column, or like each specific individual element inside of there. So we have 0, it'll access the 0th index inside of the 0th indexed array. That's what this does. This does the first indexed element inside of the 0th indexed array, and so on and so forth. And this one will it'll get the second indexed element inside of the second indexed array. And so, you can just think about it as this, as just rows and columns. Rows are the arrays. The columns are the elements. Okay. And earlier we talked about how arrays are fixed in size. Once you declare, instantiate, and initialize the arrays, you can't change their size. But that's where array lists come into play. Array lists are just like arrays. but you can add and remove elements from the array list. It's flexible. It's not fixed sized. It's like an array. It's flexible. And it can hold objects instead of primitive data types. This is where the wrapper class that we talked about earlier, basically the wrapper class allows for like methods to be applied to primitive data types. Essentially, it creates like turns primitive data type into an object, and so you put the I guess your object that you want in here. And here we have the double wrapper class, and basically it's just creating a new array list using this syntax. And the angled brackets, you technically don't have to put the object type in here again after you put it in here first. Yeah, it's up to you. It's optional. And so you can just add it like this, the dot add and the dot remove methods to change the size. And basically, yeah, you're just like progressively adding on top of it. And then remove, here's how it works. Basically, you when you remove something, it's it empties that element and then it shifts over every other element. If we were to do like import java.util.stress, if we were to do, yeah, I want to just do array list integer nums equals new array list. Well, nums.add 1. Oh, nums.add 2. Yeah. And then if we were to print nums, instead of using brackets, you can just you can access the elements via .get, and if we want to get the 0th index, we can just do that, just print out 1. And then if we want to remove, we can just do nums.remove. We can remove this 0th index. The argument inside of here is just the index, and just print it out again. And if you're following along, you'll know that it'll just print out 2, because basically we emptied the 0th index and then everything shifted over. Wait, oh, I didn't say that. Yeah, 2. It was 1. Then we emptied this index, and then it shifted over. Now it's 2. And everything, you'll see that everything shifted over. You can see nums.get 1 from 1. This was emptied. Then 2, that's the 0th index now, and then 3, that's the first index. So yeah. And .get, you already saw that, but instead, again, it's instead of brackets like normal arrays to access individual elements, you'll just use .get. And then .size is used instead of .length to basically retrieve the size of the array list. And then .contains returns is present. Yeah, basically it returns like a Boolean value, whether that element is inside of the array list. So if we do, let's just do this, and then we can do nums.contains 2. We'll see that it'll say true. If we put in 4, it'll return false. So yeah, it'll just return whether it'll just return a Boolean value of true or false, whether that element is in the array list. Pretty simple. Here's just another way to visualize basically the .remove function. It basically empties this index and then it shifts over everything to the left. Moves the 30 and then shifts over everything to the left. Here's just adding on. You're just adding on top of it. Boom, it's just allocating new memory. Boom, boom. It adds on, adding more space. For example, if you added on black into the second, if you added black into the second index, it'll shift over the red to the third index, and black is now the second index. If you add no color into the third index, it'll shift over the red again to the fourth index, and no color is now the third index. Black is untouched; it's still the second index, as up here. So yeah. And homework, if you have questions, post in the Discord. Uh, Again, DM any of the instructors, and yeah, and that's about it. So I hope you have a great day. Thank you.